Welcome to this Xtralis instructional video on how to configure a VESDA VES detector. As we're already connected to the VESDA VES detector, connection options will be covered in another instructional video, both wired and wireless. Here we simply select the detector, double click on the detector icon, and our programming parameters are brought up. So we'll move across these tabs here where appropriate. So the first tab is the General Settings tab. In this way here we can select the name of the VESDA detection network and the actual name of the detector itself. Shown below here is the serial number and the desired VESDA address that we choose. VESDAnet parameters are on the next connection tab. Here we choose which is the preferred communications port. On large networks we should be alternating the preferred port from A to B, keeping even numbered ports for even numbered detectors for port B and odd numbered detectors for port A. We can also choose whether the detector will be open-ended or not open-ended. The next connection tab we've got relates to Ethernet, which will be covered in another video, Wi-Fi similarly, security, which also relates to these connections. The next connection tab is to do with the smoke thresholds. These are the thresholds in which the detector will activate relays and provide outputs. So we can see here on this tab there's quite a lot of information. Firstly, let's look at the daytime information. We've got parameters for day and night. Under the day section we have 4 sectors, sector 1, sector 2, sector 3 and sector 4, which relate to the pipes 1 to 4. And also the alarm thresholds here, alert, action, fire 1 and fire 2, in increasing order of thresholds. So we can see here for sector 1, all of the thresholds are slightly different to the other sectors, and the same for the nighttime thresholds. Nighttime thresholds are generally more sensitive because this is when there is less activity on site and smoke detection required to be more sensitive. So we can simply select this button here, set all to sector 1, and that will mimic the threshold settings for the remainder of the pipes. So moving down the tab here we've got significant smoke change logging, which is how much the smoke obscuration changes will be logged at in the event log, and also significant smoke change logging connected through the VESDAnet. We've also got some scanning attributes here, as this detector is a scanner and will scan for smoke and display which corresponding pipe the smoke is in. So the sector scan time is 8 seconds, which means it will scan a pipe for 8 seconds before it determines what the amount of smoke in that pipe is. And there's a scan delay time of 3 seconds, which means the smoke will have to be over the scan threshold for 3 seconds to initiate a scan. The scan threshold is basically the alert threshold divided by the number of pipes in use. So in this case, if our alert threshold is 0.1% obscuration per metre and we have 4 pipes in use, the detector will commence scanning at 0.025% obscuration per metre. Moving down the tab, we've got alarm level changeover times. These relate to day and night settings. So anything that is selected as a work day will use the daytime settings, and anything that is not selected as a work day will use the nighttime settings. The same here for day-night changeover time. We can enable that, and this will initiate a time clock changeover. So at 12 AM daytime will start, and at nighttime you can specify what time you would like nighttime to start as well. Holidays will also use the nighttime thresholds. These are the more sensitive thresholds generally, and this is a once-off event, and each time you start holidays you can select the date. You will also have to specify the end of the holidays and apply that. Okay. So moving on to the next, we've got the airflow parameters, and in this case we're using all 4 pipes, 1, 2, 3 and 4, and so we have ticked all 4 pipes underneath here. For example, if we were not using pipe 4, we could simply untick it. Okay. Significant flow change relates to changes in flow that will be logged in the event log. Time delay for a flow variance is set here to 250 seconds. You can set that as low as 1 second or 0 seconds if desired. So which means that once a detector's flow has been normalized, the normal flow will be equated to a setting of 100%, which is individually settable for each of these pipes 1, 2, 3 and 4. So for example, I could have a lot tighter flow monitoring on pipe 1 than pipe 2 if I chose to. Down here I can also use this slide to set the aspirator speed. So you can see here I can ramp the aspirator speed up from 1 to 7 or 8 or even 10 and hit apply, and that will cause the detector aspirator speed to ramp up. Anytime you change the flow parameters on this screen, particularly down here with the amount of pipes in use and the aspirator speed, you will need to renormalize the detector. We can also choose when we want to do valve tests. We can do a valve test once a week or every day or every 6th day. So on the next tab is the filter time. This is simply a time in days when the filter needs to be changed. So the next tab is a sector name. We can assign a name to each pipe or sector. In this case we've used north, east, west and south, so that when you get an alarm or a fault, displayed on the detector will be the corresponding sector name. Referencing is a feature that VESDA has always used. We can choose to enable referencing or not enable it, and if we had another detector on the VESDA network, we could use this pull down menu here to select another detector. We don't actually have another detector on this network. So with the referencing, we've got the delay time in minutes and also a dilution factor in percentage. So this means if we were to enable referencing, how long it would take the smoke to get from the reference detector to this particular VESDA, which could be 1, 2, 3, 4 or 5 minutes, and how much of that smoke that is detected at the reference detector actually gets picked up by this VESDA VES. The next tab, we've got general purpose inputs. So we've got two GPIs. One is unmonitored, and which just relies on the presence of voltage. So in this case, the unmonitored one is set to reset. When the GPI has 24 volts on its terminals, it will reset the detector. And you can choose from 7 different parameters in this pull down menu. Okay, the other one is a monitored one, which means it has a resistor in it, and it monitors for the presence of that resistor. And when that resistor state is changed, then this general input function will be activated. We can also choose to lock out the button on the front of the detector, which will prevent people from resetting or isolating the detector. The final tab in the programming options is the relay tab here. And if I scroll down to the bottom, we can see here that these are all the events on the left hand side that will cause the corresponding relay to activate. The corresponding relay with a tick in it will activate. The relay numbers are shown across the top here. There's 12 relays on this VES detector, and you can choose whether the activation of these relays will latch, which means once they activate, the detector will need to get a reset command to reset the relay, and also if it beeps as well. So for example, if this relay here, fire 1, which would be on sector 3, if that were to activate, then relay number 6 would change state, it would latch, and it would also beep. So these are sector specific actions that can be applied to each of the following relays, and also latching or beeping. And that concludes the instructional video on how to program a VESDA VES detector.